Today is the next theory lesson on mechanical devices, and we will be looking at rotary systems. Can you turn to this page in your booklet and then write down the following learning objective? I will learn how cams and followers, gear trains, pulleys and belts can be utilised to create movement in products. Pause the video here and write down that learning objective. Fantastic. So there's a lot to cover in this section, but it's hugely important to use mechanisms to change, to utilise different types of motion and movement. So we're going to look at cam, a rotary input motion into a different output motion. So it takes the movement of going through a mechanical device, through a cam and follower system, changes that round and round motion into a backwards and forwards along a straight line motion. So up and down. So this red part here, this is the cam. Cams come in lots of different shapes and sizes, but they all rotate. So when it rotates, this thing here, which is called a follower, moves up and down. So when this rotates, it changes this mechanism. Whatever was on top, it's taking a rotary motion in things like pistons and turbines to create movement and to create pressure in lots of different shapes to create a different combination of movement. So cam will come with different rise, fall and dwell. The rise is movement down, and dwell is when the follower does not move at all. So when I rise, it's talking about the follower moving up. When I'm talking about fall, it's the follower moving down, and dwell means that we can see a rise and a fall, but no dwell. The follower is consistently and continuously moving. Notes in your table on that first page. So the first type of cam is an eccentric cam. It's around aft, or the centre of rotation off centre. So where the slightly off centre, this means that it goes around like this, allowing this to move up and down. So the follower at the same speed, consistently and continuously without stopping. Pause the video here and get. Okay, so next one, a pear-shaped cam. The cam is shaped like a pear or an egg, and the center rotation is in the center, and it has a rapid, so fast rise and fall, followed by a long. It does not move. Up, down, stop, up, down, stop. And then next we've got a snail or a drop cam. So the cam is shaped a little, it's a circle with a step cut into it above. And that means that the follower has a very long dwell time. The follower does not move, followed by a quick rise and a very sudden drop. And all the others, it can only be used rotating it in this direction. If you rotated it in the other direction, this step, so a snail cam is when a follower has a long dwell followed by a sudden drop. Get that information into your tables and then press play when you're ready. R-shaped cam. So sorry about the speed of this, I couldn't figure out how to slow down this GIF, but it's a bit erratic, but at least it still shows us the movement. The follower has a slight rise and slight fall with no dwell period. So it goes up, it goes up a lot, then up and down a lot. So it goes like, it moves up and down. So at the top of its rise, it does a little up, down. At the bottom of the rise. So we've got eccentric cams. We've got snails because of the change in motion, the type of motion that it creates, the movement. Another type of So, GCSE, we only really need to understand what a gear train is, and then gears is not a simple gear train, so we're going to keep it at the bare minimum at this tension and torque. And they are two or more gears joined together, is 2 gears in a gear train. We've got one gear that is called the drive, is normally larger, causes the driven gear to turn in the opposite direction. So if you look at A, this is the drive gear. When the teeth are connected to a driven gear, it causes the driven gear to rotate in the opposite direction on. What can you tell from the speed of rotation? Which one is moving faster, A or B? Smaller gear with the fewer teeth turn faster than the larger gears with more teeth. Each of these little sections are called gears. Not gears, each of these are called teeth. So the larger, the lower it rotates compared to a smaller gear with fewer teeth. And we're going to use those teeth numbers to find this. So we've got a practice question here which you will need to answer in your book. This is going to be a perfectly answered revision of how to get to the correct answer. So if the drive gear, this bigger one, in a simple, and the driven gear has 150 teeth, what is the gear or velocity? Our formula is the velocity ratio equals the number of teeth on the driven gear divided by the number of teeth on the drive gear. So it has 75 teeth. So it's 150 divided by 75, which gives you driven gear would rotate 2 times. This gives us a ratio of 2 to 1. Once. Okay, our final type of rotary system are wheel shape. It's something that's wheel shaped, this section here, with a groove that allows a cord to sit inside it. This part is the pulley. Drives transfer movement from one rotating pulley to another. So if there was another pulley down here, it changes the direction of force, making it easier to pull down than lifting up. So pulleys are used. So lifting this box on its own would be quite difficult compared to pulling down on this rope. So it gives you a mechanical advantage. This is a belt drive, so this is called a block and 2 or more pulleys that can be used in combination to reduce the effort required to lift or move a heavy load. The easier it's going to be to lift up the load. So if you have 4 pulleys, it's easy to pull this up, whereas the one with just 2 will be twice as hard. You calculate different things as part of a belt drive. As part of 2 pulleys, the rope that goes through, these 2 here are between the pulleys and the beginning point. So between the beginning point and here is another supporting rope. This rope is not supporting. This is the rope that you would pull down on to lift this tent. The formula we use is force equals load over number of supporting ropes. So our practice is required to lift the load. This is the load. So the workings. We know that force equals load divided by 10 newtons, which is the load, divided by number of supporting ropes, 1, 2. That means 5 newtons. But also, it might ask you, what is the mechanical, and in every single situation, the mechanical advantage is equal to the number of supporting ropes. Mechanical advantage is 2, because we've got 2 supporting ropes. Next one, we've got a block and tackle system, which has, we have got 1, 2, and 3. This is the starting point. Between here and here is 1, 2. Got another one, and between pulley 2 and 3, we've got a third one. So we've got 3 supporting ropes. We are trying to move 3 need. So as we know, the force will be equal to the load divided by the number of supporting ropes. So that is 300. What is the mechanical advantage of this block and tackle system? Say it to the screen. If you said mechanical advantage in a block and tackle system is equal to the number of supporting ropes. 1, 2, 3. Okay, guys, for completing this theory lesson, I know there's a lot of information in here. If you've missed out any sections over the